Hello students, in this video we will learn about the working of a potentiometer. Previously we studied about meter bridge. In a potentiometer, you see carefully, there are wires in this. There are two types of potentiometer, one with 10 meter wire and another is with 4 meter wire. Now here there are two terminals. This is terminal A and this is terminal B. Now what we do? What is the purpose of a potentiometer? Potentiometer is used to compare the EMF of two cells. This cell which I have got is called Daniell cell, and another cell I have got which is called Leclanché cell. Ordinary dry cell is basically a Leclanché cell. Now, I am not going to use them because it will become more complex. What I am going to do, I am going to use an ordinary 1.5 volt Eveready, Novino or any company cell. One is a little bit old and one is new. What is the potential difference of this cell? Our EMF of the cell is 1.45 volt basically, right? 1.5 is more than really that. Okay, so I'm going to compare these two as an example. Right, I will introduce certain points. Already you know there is galvanometer which has a center scale. It is going to be used for measuring small amount of current. And you have resistance box. Resistance box measures the resistance. You can change the resistance, but the values are only in multiples of certain number, like 2 ohm, 3 ohm, 5 ohm. I can't keep something in between. Now I got a rheostat, right? And that rheostat is going to be, we can change the value of the current. We can change the value of the current. This is variable. Here it is 1, 2, 3, 5. That is how numbers are fixed. Here by changing this, I can change the current and the resistance can be changed. And here there is a lot of wires which is made up of nichrome is wound, okay, and this is moving just like a jockey. And I got an eliminator and I got a single key, and then an ammeter, and from there ammeter it comes to rheostat, and rheostat it is come to the point here. Now look at this diagram. Yeah, in this diagram what I have done is the primary circuit. I have connected to a battery, connected to a key, I have taken an ammeter, I have connected a rheostat, and I have brought back to the point B, and here I have taken 4 meters wire. Now how do we do the experiment and how are we going to compare? Again from the point A we connect cell 1 and cell 2, and then we connect it to a two-way key. I hope you can see this here, right? Two-way key is there. There is one center key which is going to the resistance box, and left one, if I connect it between center one and this one, I will find that first cell will come into the circuit. Now if I remove this, right, and put the key into this one, between the gap between the point, this I call it as 3. 1, 3 will bring the first cell, and 2, 3 will bring the second cell into the circuit. Now I bring the first cell into the circuit, and I got a resistance box, and I got a galvanometer here. Now why should I connect the resistance box here? Because the current may fluctuate and sometimes the galvanometer coil will get spoiled. So we connect a resistance box and remove, for example, let us say 1000 ohms or 500 ohms or any amount which is suitable for the instrument. You can put it. This is only a demonstration, right? I am not exactly doing the practical with the help with the electric current passing through. Yes. Now I brought the first cell into the system, okay, and the moment it is coming to the circuit, I take the jockey. When I take the jockey and I slide it from the point A on the wire. This wire is made up of constant and right? First I keep it here and I keep it here and see that is not actually necessary. You can take it here, keep somewhere at different point, 80, 90. When I go to the next wire, 100 centimeter is finished, 120, 143, 150. So the number goes on increasing. 100, then afterwards till 200, then it is 300, then till 400. Usually 4-meter bridge is sufficient, 10-meter bridge is much more accurate, so many times we use 10-meter also. So when I bring the cell 1, and if it is epsilon 1 is its EMF, I find the balance length. You know the balance length when the current will be 0. The galvanometer will show no deflection, and that is the null deflection. At the null deflection, let me say if I note it to be equal to 100, I have come and I used another side of scale 140. That will be balancing length 1. Okay, now for the same current, I have not changed here. I have put a particular amount of current, 1 ampere. I am not changing that. Now I remove this key and put it between 2 and 3, right? And then that means the second cell is into the circuit. Once I bring the second cell into the circuit, whose EMF is epsilon 2, then again I take the jockey and again I move it over the wire and I find the balance length. It can be any value which we will note it, maybe 168 or something like that, and we note L2. You know that epsilon 1 is proportional to L1 and epsilon 2 is proportional to L2. So now what is happening? Epsilon 1 upon epsilon 2 we have converted into L1 and L2, the balancing length, which we have done practically. So now when you watch carefully here, yeah. Now you see here A, epsilon 1, epsilon 2, 2 cells are there, two-way key, point 1, point 2, center point 3, and then I move it, there is a resistance box, and I got a galvanometer and I got a jockey. Now this is the primary circuit and this is the secondary circuit. I bring epsilon 1 into the circuit and find the balancing length L1. And then I remove the key and bring the second epsilon 2 into the circuit, and then I measure the balancing length L2. We know L1 upon L2 will give you the ratio, and you can see the tabular column which you can fill it. We have got serial number, current is fixed for a particular set of values, then L1 in centimeter, L2 in centimeter, then L1 upon L2, and then we come to epsilon 1 upon epsilon 2. This is one of the purposes of potentiometer, that is comparison of EMF. We can use the same thing to measure the internal resistance of the cell. That time the circuit will modify little. We need only one cell and then we need another resistance box. There we will compare epsilon and then potential difference by putting a resistance, and that will give you internal resistance. That we will do it theoretically on the green board. So I hope you understand the whole process of potentiometer. So the circuit is very clear, two-way key, we use galvanometer for balancing length, and then I want to take second set of reading. What do? I just move the value in the rheostat. When I move the jockey in here on the rheostat, the current will change, and that current may be 2 ampere I can keep, and again cell 1 balancing length L1, cell 2 balancing length L2. So we can calculate like that 5 readings we can take for different current, and then finally the average of that can give you a clear picture of the EMF between the two cells. I hope you understand the concept, and in the next video we will see all this theoretically. Thank you so much.